question 26 is actually a very interesting question. I can see that you have attempted to locate it successfully the unit of the mu naught and the epsilon naught from the data booklet, right? From the table of the constant. Good job. But then when you multiply them together, you even simplify the meter already. You got this one. It's actually correct, but that's not the answer to this question. Why? Because if you pay attention, you can see they have another keyword here, fundamental, right? So what does it mean by fundamental SI unit? There's only 7 of them to be the fundamental, which is if you measure the length, it should be in meter. If you measure mass, it should be in kilogram. Time second. Electric current, it should be in amperes. Temperature in Kelvin. The amount of substance in mole. And the last one is the candela to measure the luminous intensity. So actually we need to do another step. We need to simplify this one back into fundamental SI unit. And because we have Tesla here is the unit for the B right magnetic field strength. So it's not fundamental yet. And also like coulombs here, the unit for the charge, the Q, is not fundamental yet as well, and Newton as well. Newton is the unit for the force, right? So we need to do some more step in order to get this one. And if you remember, I have mentioned a lot of time about dimensional analysis. This is also one of the very key principles in physics that help us to double check if our math is correct when we have the unit kind of matching with the formula, right? So from the formula, basically we can derive the unit of this one much more effectively. So if you have a look at the data booklets again and try to find some formula that contain the mu naught in it, you can find there's a formula like the F over the L equals to mu naught I1 I2 over 2 pi r, right? So what is it? The F here is actually the magnetic force that we can determine over a unit of length between the two current. So for example, if we got current I1 like this and current I2 like this, if they're in the same direction, they will pull each other, they will attract each other with a magnetic force. And because usually we consider the case where you have a indefinite length of this one, the length reaching to infinity, so we need to just find the magnetic force per unit of length of each of the wire. So and R here is the separation between the two currents. So this is just a really quick review of the formula itself. The point I try to make here is that if we want to find a unit for the mu naught here. So what is the mu naught? Mu naught is actually the permeability of the free space of the vacuum. When we got the naught here, that's simplified for the vacuum. So basically, if you put the two current here in different kinds of media, which is not, medium is a singular verb, a singular noun, different from the vacuum, then the magnetic force will change, okay? So this one is just tell us how much the magnetic force change between different medium, which is not vacuum. So here back to this one, the unit. We can see that the unit for force is 1 Newton, unit for length is meter, then unit for current is like coulombs. Oh, sorry, amperes, my bad, amperes. And this one is another amperes here. And this is like 2 pi doesn't have unit, and then R should have the units as meter. So if we simplify, we can see meter cancel out. So basically, the unit for the mu naught equals, or the mu equals to 1 Newton divided by the ampere square, right? We move the ampere square here to the other side, so we divided it. So basically it's also equals to 1 Newton's times 8 to the minus 2. Okay, so this is also another way for us to write the unit for the mu naught, which is different from this one a little bit. And oh yeah, we noticed that this one they also have Newton, so Newton and Newton can cancel out. Oh, so maybe it can help to simplify the problem. So let's see if we multiply them, what would happen. We have mu naught times with this one, the unit. So only Newton, oh, maybe just write out everything once again. This is for the mu, and this is for the epsilon, like you have over there. So now you can see that Newton, oh, my bad, this is just -1. I'm writing too fast. So let me write again, really quickly. 2 Newton minus 1 meter minus 2, okay? So we can see that Newton cancel out. So what left now is just amperes and coulombs and meter. So now maybe we just need to do another step to express the Coulomb unit itself back to the 7 standard fundamental units. So coulombs and so Coulomb is the unit for charge. So is there any equation with charge to do with these fundamental that should be related to the currents, right? So actually current is defined as the rate of flow of charge over a unit of time through a cross-sectional area. So basically here we can also have the current times with t, right? So it means that 1 coulomb will equals to 1 ampere times 1 second. Nice. So if you just plug in it here, substitute it in, it should be ampere square times with second square. So now you can see we can simplify ampere to the -2 with this one. So what left is just second square times with meter to the -2. Is that what we're looking for? That's right. Okay. I just want to add another thing that maybe you could be interested in. If later, if you just happen to take some more advanced course in physics, you will learn more about Maxwell equation, the 4 equations that describe everything to do with electromagnetic phenomenon. And in that, you will learn that if we got the mu naught times with the epsilon naught, it will equals to, oh, can you guess? Do you realize that this one is actually just the inverse of the unit of the speed itself, square, right? Yes. So actually it's equal to the inverse of the speed of light. Okay. It's just some extra information for you. So hopefully this helped. Please let me know if you have any question. I know that this kind of like a tough question because it's asking about the 7 unit of the fundamental. Okay. Thank you for your patience.